I'm Anil Kumar, and now let us understand how to simplify complex numbers. Simplify I to the power of 68 minus I to the power of 31 plus 9I to the power of minus 9. So I to the power of 68 can be written as I squared to the power of, let's divide this by 2. So we get 34. For minus I to the power of 31, we could write this as I to the power of 30 times I. And for 9I to the power of minus 9, we can write this as 9 over I to the power of 9. Correct? Minus negative exponent means the reciprocal. Now, I square is minus 1, so we can write this as minus 1 to the power of 34. I to the power of 30. Now, for that, we could write this as I squared to the power of 15 times I plus. This is 9 and I to the power of 9. Let's write this as I to the power of 8 times I. Now I to the power of 8 could be written as I squared to the power of 4 and then I. Do you see that? This is I to the power of 9. 4 times 2 is 8 and 8 plus 1 is 9. I hope this step is clear. It is a very important step. So whenever you have odd powers, we are to split them as a combination of even and odd, right? I square we know is equals to minus 1, and that is the reason why we have set of even powers here, right? We could write I square as minus 1 and then simplify. Now in this case, minus 1 to the power of 34, which is even power, will give us plus 1. Now we have minus 1 to the power of 15I plus I over, now this is minus 1 to the power of 4 times I, right? So in this exercise what we are learning is how to work with different powers or exponents of I. So I hope this exercise will really help you to understand that, and that is the reason why I'm doing it in steps, and we are doing parallel steps, kind of repeating the steps. Do you see that? Now minus 1 to the power of 15, since minus is negative number, odd number exponent will give us negative 1, right? So we get negative 1 here. In the denominator, minus 1 to the power of 4 will give me positive. So we get 9 over I. Do you see that? So 9 over I. So that gives us 1 plus I plus 9 over I. Correct? So this is what we get. Now, it is a good practice to always rationalize it. So we'll now rationalize and show you the technique of rationalization. So we have this equation equals to 1 plus I plus 9 over I. Now, in rationalization, we normally multiply by the conjugate of this term, right? So minus I or minus, we could do that. Now, the other idea is, in this particular case, we can also multiply by just I. It doesn't really matter much. I square will give me a negative sign here. That's fine, right? Since we do not have two terms here. So let us multiply and divide by I so that we get rid of I from the denominator. So 1 plus I plus 9 over, well, you can also multiply and divide by minus I, which is real rationalization, right? So I've kind of defined the rule, but I find this works, right? So let's do it like this. Plus, so we get 9I over I square. Now I square is negative 1, right? So we'll get 1 plus I plus 9I over negative 1. So this changes the sign. So if I would have multiplied by negative 1, I would have changed the sign otherwise and got positive here. So it gives you the same result, right? So I'm going in small steps so that you understand how we are getting to this result. So that plus and minus become minus 9I, correct? Now we can combine these terms. We get 1 minus 8I as our answer, right? So you can do like this. And some of you who really want to multiply by the conjugate could do by multiplying by minus I over minus I. That will be a conjugate, okay? But you'll get the same result. So you can try like that and get to the result. I hope this problem helps you to understand how to work with different exponents of the complex numbers. Thank you and all the best.